recording. So we're starting our do now problem, generating this output, the indices of a nested for loop, row column order. Think about these like coordinates. We'll have to be very comfortable navigating this when we're working with 2D arrays. Okay, and so far I've started by writing a loop like this. Fixing the formatting, plus, in all the wrong places, and plus to add some strings together. I guess we'll just print row again as a placeholder before we introduce that second loop, and then add our closing parentheses like that. That was my formatting. Okay, cool. Nice. And then even we can add in the tab character. It does the spacing a little bit better. Oops, wrong way, wrong backslash, this slash. I think it's tabbed out. We got a slide on it, slash tab. Yep. Okay, close this window, go here. Now we need to make this stuff repeat. We're going to have an inner loop. This one controls the number of columns, of which there are still 10 columns. We'll start call going at 0, column is less than 10, and then call plus plus. Then for here, we should have this number match up and be call, and then we'll have the row column order pairs or coordinates displayed as matching with that picture. Oops, looks like I forgot something. I have all the right numbers here, but they're not all separated line by line. For example, when we get to 0, 9, right here, there should be a new line so that 1, 0 begins counting on the second line. That doesn't happen, everything's here in one line. So, right in between, or right after the inner loop, but inside your outer loop, we need to write a system.out.println to help us with that spacing. Cool. Now we have that. Oh, do we? Yeah, we do. The diagonals, all the numbers match. 0, 9, 0. Double check the slide. Did we get set output? Yeah, I think so. Should match up. The spacing's a little bit off. Maybe I could add that like here, add a space. Whoa. One space like changed it so much. I wonder if that's like the tab now that's affecting it. Make it bigger. Yeah, it doesn't even fit across my screen. Who knows? How do I exit full screen? Processing, stop. F11. Uh-oh. Wrong set of buttons. Alright, now I'm stuck in processing. Full screen. So that's your do now. This simple nested loop, printing out the coordinates and or indices. We'll go now to this point to go over some, I guess a mistake I had in both classes. Kind of ran out of time on Friday when we were getting this bunch of grid, getting the game of life working. So I think I left off roughly here. So we went over the initialization of the constants for the game of life assignment. We started to properly initialize our 2D array of buttons. First, creating the apartment building itself to have 20 rows and 20 columns. Then we go inside each apartment, individual apartment, and lease it out to an individual life. I talked with Mr. Simon and we fixed the slides. One of the mistakes that was present was not having the indices here for buttons. Previously they looked like this, and we got a type mismatch error, which means we had a 2D array of buttons on the left-hand side, but expecting life objects on the right-hand side. To access individual life objects, to initialize them, we need to go into a specific row, a specific column, and say, this life over here, like at position 5, you are now created. That was one of the big mistakes. And then, in order to get a proper output, this bunch of buttons to appear, you need to scroll down into the life class and uncomment these 2 rows. On my program, it was lines 73 and 74. We need a width and a height. This stuff needs to be uncommented so that when you press play, the grid knows how to draw itself to the screen, and then you should see a wall of buttons. Come on, Replit. Okay, let's give it a moment. It's waking up just like many of us this morning. Come on. There we go. We see our sketch. The buttons shall soon appear. There they are. You can make this output window bigger. You can see that 20 by 20 grid. Scroll down. There we go. So it fits the screen. You press on a button, it disappears or reappears. This is the Guido library that we went over last week. It helps us with a graphical user interface, GUI. Right. So real quick, that's the Game of Life assignment, at least the first 8 steps. After this step, you are following through, where is it? You are going to follow through and implement those rules of Game of Life, those 3 checks of your neighbors or surroundings, and either living or dying, appearing or disappearing. And you'll notice, like in previous programs, we have very useful coding back problems that tie directly to this coding assignment. Is valid on a 555, is valid on n by n, and count neighbors being true. If you solve these, you will have done a lot of the work to get Game of Life finished. Okay. On to some coding bat review, as we didn't get to do much last week. Looks like there were a couple requested from Recursion 2, which was due Friday. I haven't gotten to grading that just yet. Let's see. count8 and countOnes was requested. And if you want me to go over any from the Minesweeper coding bat problem set due this Friday, please post in the chat. Today's the day to get some coding bat reviewed and done. Okay, so count8 and countOnes, we'll talk about these 2. Ooh. I wasn't signed in, so my progress wasn't saved, but I'm kind of left off on this problem with like counting individual 8s, right? Every 8 has a weight of 1, and it was the 88 part that kind of made this problem a bit more confusing. We'll have to recreate the count7s, I guess, that solution. And I think the trick here was just the mod. Sorry, gotta change my brain to think of again in recursion. Okay, so with this one, remind myself, if I'm isolating the ones place, my number is less than 10. And specifically, I want it to be remainder 8, right? So if I mod by 10 and it equals, mod by 10 and it equals 8, I should be returning 1. Else, I need to do my recursive stuff. I have to go in and return something. Return count8 n, was it divided by 10? like that. Something seems off. My code is not quite there. Yeah, this one only returns 1 each time. Alright. So I got the base case down, and then 88, it should be returning 2, but it only returns 1. Looks like I have to keep counting here if I am... Yeah, it looks like I have my base case wrong. So what's up? Should I have a separate else if n mod 10, well, yeah, is my base case too specific? So this one means it's a single digit, right? If I'm less than 10, then I have to do a check. I'm pretty sure this code is the same. Right? I think it's here. So if I'm recursing, I have to add in what I'm at plus the people before me, right? Anyone want to help me out on this Monday morning? Is that right? Oh, I forgot about 0. Okay, thanks. If n is less than 8, return 0. Yeah, we got some else ifs. Okay, now which one should it go first? If n is less than... This may work. Okay, sorry. It's been a while since I coded up my recursion. Still not quite there. Alright, if n equals 0... Alright, can I cheat? I think I will cheat at this point. I'm gonna go borrow this student's code. The 88 part is accounted for? Yeah, right here in this else if. So this one I'll comment out for now. I want to explain the reasoning behind it. Remember, from this problem set, we're just using recursion, not nested loops. So that's what made this problem a bit more difficult, using just recursion with this. So thank you for the help. This is what it should look like. I was close in getting there. Okay, so there's two base cases and then one recursive bit. Or is that right? No, one recursive bit. Sorry, brain's not working. All right, so this is our base case. If n is less than 8, you return 0. In the chance that your single digit is equal to 8, you add 1 and add up all the stuff that came, I guess, after you or before you. Okay, that's the mod 10. And otherwise, if you're still a really large number, you will just keep recursing, count 8 divided by 0. Think about this like 0 plus this, okay? Like that. And so the tricky part is the rule with how do you account for double 8s. So this student, when they copy and pasted their answer to me, they checked it individually, right, with this statement. N mod 10 equaling 8. Okay, so that's the ones place equaling 8. And then they check the tens place to see if it's 8. And that will isolate the 88 rule. Because when that happens, you need to add 2 instead of weighting by 1. And then keep recursing. So here's one version of the answer. Okay. Alternatively, you could mod by 100 and check that it is 88. When you mod by 100, you're looking at two digits at a time. So you don't have to check separately the ones place and the tens place for an 8 and an 8. And I think this should work the same. Oops, I didn't delete too much. Yeah. Okay, this is the single digit check for an 8. This is the double digit check for an 8. So that's how we thought about it. I think this is the hard part. It's not so much another base case, it's more like a different recursive rule. Notice you have an else if here. It's a special weighting. The recursive part stays the same, but notice these numbers out in front changed. Right. On to count1s. Let's hope it's a little bit easier, or my brain's warmed up enough. This is count8s from recursion 2, due last Friday. Some people are still working on it, so that's why we're reviewing it now. I think we talked about this one, maybe not for this class. So this one uses the same kind of mod and integer division to help you isolate digits. We're counting ones this time. So it could be it's not 4. So our base case, we need to code that up. We need our recursive part. So now we're checking if it is equal to 1. So if n equals 1, actually, sorry. Oh, yeah, let's go with it. And then here, return n count ones n divided by 10, right? Will this logic from the previous problem help us out? Do we need an else if? Let's see what happens. I think my brain is still fixed in this manner of thinking. Yeah, we Stack Overflow. So when we mod 10 and our thing equals 1, that means it's evenly divisible by, no, sorry. This is the part where we return count ones n divided by 2. And here, if our number n, I guess this is the one where we return 0, right? What's our base case? I think that's the root of my issue. I'm unclear of what my base case should be. One is bigger than or equal to 0, return 0. So all the other numbers. Sorry, I think that. In the off chance that we get to be negative, So logic-wise, it's very similar to the previous problem of count8s, or count7s even, but now our if statements change since we're looking for the numbers ones. We could have sequenced it a little bit differently. I think the important parts is looking to see like the weighting rules, add 1 or add 0, and then having the proper base case. Seems like this is my sticky point this morning. Couldn't quite wrap my head around it. If you're less than 1, then you return 0. You'll notice when I didn't have this, it got to Stack Overflow, right? In the cases where it kept checking, there was a 1 present, it didn't know when to stop. Thanks, class. So those are the two from last recursion. Those are the two problems from the recursion 2 problem set. Are there any requests to review some from the Minesweeper problem set due this Friday? Can you post it into chat? Okay, so if there's no requests, I figured I'll do the first one, is valid 5 by 5, since that's what you'll likely be doing. Count neighbors true. Okay. I got 7 minutes. Actually, I only got 2 minutes, so maybe I'll just talk about this one. I think it's easier, and we'll save count neighbors true for tomorrow or Tuesday, or tomorrow or Wednesday for block 1. Yeah, Wednesday. So this one returns if it's a valid. So this one, it'd have to do some index checking, right? There is no show hint button that gives you a 5 by 5 grid. If you're checking to see if this thing is on the grid, right? For example, 4, 3, that row column position is on your 5 by 5 grid. But suddenly if you go like 9, 5, that doesn't exist within your 5 by 5 grid. If the row is like 9, and whatever the column is, you're already like out of luck because your row and column numbers are out of bounds. That matters, right? If the user clicks something outside of your grid, you can't let them do that. Can't let them shoot themselves in the foot. So in this case, it's some index checking, right? Whatever number they give you, right, in a 5 by 5, if row is greater than 5, then you have to return false. If your column is bigger than 5, then you return false. Otherwise, you can return true. And I think that's it here. Nope. I'm caught. My logic is off. Else if. Oh, it's equal to. Because I'm starting counting at 0. 0 up until 4 and 5, right? And then accounting for negatives. Oh, Mr. J. Or row is less than 0. Okay, and then this one, column's less than 0. Can't have negative indices. There we go. Ta-da. We'll save count neighbors true for Wednesday. That's it for Monday's class. See you all on Wednesday. Please work on your Game of Life assignment and Minesweeper. See ya.